So we're here at Linaro Connect.
Correct. So my name is Jeff Underhill. I'm the Director of Server Programs at ARM. We're here at Linaro Connect Hong Kong. We're just kind of getting towards the end of a pretty intense week. A lot of sessions discussing open source software, status of the ARM ecosystem. And the last day of the event here, we have a bunch of demos. And this one in particular, we're going to talk to some guys from Cavium. They have their ThunderX platform here, which is an ARM v8 based server. 2015 is really going to be a very interesting year for the server program. We got multiple silicon solutions in market. We got initial tier 1 platforms shipping. The open source software ecosystem is coming along at a real rate. And so let's take a look at some of that. So first of all, I'd like to introduce you to Prasun from Cavium. He's going to walk us through the ThunderX board and SoC and share some of the details of the hardware we're looking at here, and then we'll start to look at some of the software. So, Prasun, why don't you tell us what we're looking at here? It's great to see ThunderX.
Sure. So I'm Prasun Kapoor. I'm the Director of Software Engineering for Platform Software for Thunder. And what we're trying to showcase here is the high-performance 48-core ThunderX ARM-based device.
Yeah.
And the main purpose of this demo is to show virtualization features of the ThunderX SoC. And we have a couple of platforms here and a couple of hypervisors that we are showing running on them. So this one is an internal eval board, which is running the Zen hypervisor. And this, I think Manish will talk through the details of this demo. But the primary thing we are trying to showcase here is the ability of directly assigning virtual functions to virtual machines. And on the other side, we have a KVM demo that's running on our rack-mounted 1U platform. And this is running KVM. And the objective of this demo is similar to what we're doing on the Zen side, where we are assigning SATA controllers and VNIC virtual functions directly to virtual machines which are running different OS distributions.
All right. So so can we get a demo of? So hello. So who are you?
Yeah, thanks.
We start over there. Okay. So hello.
Hi. My name is Manish Segri. I'm a technical lead at Cavium Networks.
Yeah.
And I work on Zen Hypervisor. So we are showing a Zen Hypervisor running 7 virtual machines and showing different distributions.
So is this illustrating what happens right now?
Yeah. So you have a ThunderX with different virtual functions. And these virtual functions and different SATA drives, these are directly assigned to particular virtual machines. And as you can see, the blue arrows show the network virtual function PCI pass-through, and the green arrows show the AHCI PCI pass-through. We're showing different distributions running in different virtual machines. We have a Ubuntu Trusty, we have a MySQL running in OpenSUSE, we have Open Embedded LAMP image from Linaro, which is running in Apache, and we have Ubuntu running ODP applications, which are traffic generating applications. Also, we are running a Twitter application, which is getting feeds from Twitter based on different search criteria and storing all these tweets inside the MySQL database. So we have two kinds of network. One is a directly assigned network device, and the other is a PV network, where you can see in the black arrows. So the DOM0 has the Zen bridge, which is giving IPs to different virtual machines using a virtual interface. And there is a DHCP server running on this machine in this network. And on this machine, they're also showing a VNC on DOM0. And these are the different consoles. As you can see that the Excel list, which shows all the list of virtual machines running, we have the OpenSUSE, Twitter, and I can just show you again the time that's they're running, and there's the number of vCPUs and the memory that's they're showing. Right now we have this. I just run again this script.
Right.
Okay. And the script is getting.
So
yeah.
So each of these windows is showing. So basically, on right here on this board, you're running 7 virtual machines at the same time.
Yeah.
All right. So what's the main purpose of all these virtual machines and doing that kind of virtualization?
So there's couple of main target areas that we're trying to hit. So in cloud applications where people want to co-locate multiple workloads, and also the network function virtualization use cases where a lot of network functions are going to be co-hosted on a single platform. So since this platform has 48 cores and the ability of directly assigning devices to those virtual machines, I think this is an ideal platform for running multiple virtual functions on the same platform.
So virtualization is a big deal for ARM servers?
So I think it's one particular use case, right? We're going to see a variety of solutions, people using bare metal, some people using virtualization, some people using containers. What we have here is a technology demo that shows a broad spectrum of those solutions focused on virtualization, but you've seen Open Embedded, you've got OpenSUSE, Ubuntu, Red Hat, Cavium, Zen, you've got MySQL, you've got Apache, just a variety of components that you would find, combinations of those in a typical solution. And so really it's kind of a technology demo at this point.
So virtualization is a good way to use all the cores and everything?
Yeah, it's one way to achieve, I guess, full performance entitlement from a machine. You've got 48 cores in there.
Which is a giant. I would say it's the biggest ARM.
This is an impressive chip, right?
I would say maybe it's the biggest ARM processor ever. Maybe.
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 I can't make that claim.
So-
It's certainly a big one. Yeah.
And so there's also when people talk about OpenStack and stuff like that, is that also on the virtual, or is it going to be a different kind of way of doing ARM servers?
No, so OpenStack is kind of a cloud management framework that sits on top of virtualization. So virtualization is a underpinning technology, if you will, and then it provides storage solutions, image services, compute. So those two things kind of go hand in hand. But,
And the virtualization is something that your future customers are really looking forward to, right?
Absolutely, not just future, the present customers are also looking for this solution. And so what we're showcasing here is the enabler technology for OpenStack. So once we have the hypervisors running robustly on our platform, those virtual machines can be managed using OpenStack.
So let's check this out. So hello.
Hello.
So hi. So who are you?
I'm Vijay. I work with Cavium majorly on the virtualization technologies. Here we are to demo both the virtualization hypervisors, type 1 and type 2 hypervisors running here. Here I'm taking care of the.
So you have a ThunderX in here.
Yeah, this is a ThunderX chassis board.
Is one ThunderX in there?
You have one ThunderX. It comes with two socketed board with 96 cores as well.
So it can have potentially there's 96 cores in this.
This board has a 48 cores and it can come with a 96 cores as well. We have that.
Right.
As well. And here you can see this. It is booting a host kernel from the USB port, and you have 4 SATA controllers which are running with different distributions with the PCI pass-through, direct device assignment.
Yeah.
So here you can see this demo where we are assigning direct device assignment through PCI pass-through for all the distributions running as a guest on the host kernel, on the Cavium hypervisor, and we have virtual functions directly assigning to the virtual machines running on the Cavium hypervisor.
So it runs Ubuntu, OpenSUSE, and these
Red Hat, and a simple BusyBox application.
And it could run at the same time, or how
all
does
are
it
running
work?
at the same time.
All right.
And you can see here all are running at the same time. You can have a Cavium host, which is running a simple BusyBox one, and here is a OpenSUSE test running, and Red Hat test running, and Ubuntu, and a simple BusyBox with a device assignment.
So everything at the same time.
Yeah, everything at the same time.
And what's the purpose of running everything at the same time? It's just demo.
Yeah, this is a demo, and that is the whole point of having a virtualization. You can have all the virtual machines running at the same time on a hypervisor with it's having its own device assigned, either Ethernet device or a SATA device.
How many is the maximum to run at the same time?
You can run as many as you want.
As
To
many.
utilize complete hardware capability, having 48 cores, it's it's a big system having a 40 cores.
You can
So
run 100
as many
things at the same time.
Yes, you can run as many as possible.
And is it a great way to use the multi-core
Yes,
system
it's-
to have that
yes,
kind of
the-
stuff?
The whole point of virtualization is to utilize the hardware to the maximum possible extent. To utilize the hardware.
All right. So how's it been to work at Linaro with Linaro and getting things optimized and getting to the stage?
It's been a great journey. We have been a part of Linaro for a number of years now, and we have seen the ARM v8 ecosystem evolve. And now I think it has finally reached a point where we can run such complicated demos. So it's been a long journey of both software and hardware enablement over the last couple of years.
It's pretty awesome. And how about for you? Like the ARM v8 was announced 3 years ago or a little
Yeah,
more?
something like that. So I've been at ARM for about 5 years now in the server program. So it's like, I mean, it's super exciting to get to this point. We've made so much progress. We're seeing, high-end 64-bit systems come to market. This week we've seen a lot of activity on the software ecosystem front. That's maturing nicely. A lot of the foundational pieces are in place, as you can see here from the demo. So I think we're at that inflection point. 2015 is going to be the year where we'll see first deployments, and then 2016 is when I think we start to see that nice ramp taking off. So yeah, it's
And
exciting times.
it's really smooth. It's really working out great, and the potential is huge, right?
Yes, absolutely.
And so this is pretty awesome. So been talking a lot and working with people have been working with emulators and stuff, and now they can work with real hardware.
Exactly.
Let's check out some more you have to show here.
So this is the Twitter applications running. So we have a Python application which is getting feeds from Twitter, and this is saving the tweets in the MySQL database over a PV network. You can see we are searching on the keyword India, and these are the number of tweets it's getting, and that's the number of tweets it's like saving in the database. And we have a demo which is showing the ODP traffic generator application, and this is the receiver application. These are running in different virtual machines. They're dedicated virtual function, and they are connected directly. And this is the Apache server which is streaming the 4K video, and this is the top. So it's not using much of the.
So it's easy. It's really easy for the ThunderX to do 4K video streaming. So that's just one of the things that can happen. The streaming video to over here.
The video is stored in a SATA disk over here, and it's streamed through the PCI pass-through network. And this machine is running a VLC that's streaming the video
Cool.
on this monitor. And this is a transformer.
Nice. And you've been running this the whole week, right?
Yeah.
You've been showing it, using it, showing it off, and that's very cool.